Hello again, YouTube. This time I'd like to start off with a quote from Sam Harris. He says, "Every one of the world's great religions utterly trivializes the immensity and beauty of the cosmos. Books like the Bible and the Quran get almost every significant fact about us and our world wrong. Every scientific domain, from cosmology to psychology to economics, has superseded and surpassed the wisdom of Scripture. I will launch a video series which serves to address this very issue. How do science and the Bible relate? It is improper to answer such an objection without first clarifying our terms. Dictionary.com defines science as a systematic knowledge of the physical or material world gained through observation and experimentation. It is important to note that science is not nature itself, but rather our interpretation of nature through observation and experience. Also, despite the popularity of the young Earth creationism view, which pictures the world to be about 6 to 10,000 years old, young Earth creationism is just an interpretation of the Bible, just one among many. So there is not necessarily a falsification of the Bible by the external world, but a clash of interpretations of each. In the upcoming videos, I will offer what I feel is the best interpretation of both Scripture and science, but for now I will address the issues of how science works and whether it is reliable, the information about the various types of scientific methods employed, as well as the examples are found in Origins, a reformed look at creation, design, and evolution. To begin, the first of three models laid out in this book is experimental science, which is done in the fields of physics, chemistry, ecology, geology, and molecular biology. Experiments are accessible in the lab. The scientist can measure what is happening, monitor the experiment from beginning to end, destroy the products of the experiment, and start over again at any time. Many of the variables can be controlled, and external variables can be removed. Experiments can be repeated as often as necessary to confirm the initial results. Basic assumptions, such as the consistency of physical laws, can be tested and repeated. Predictions can be confirmed or contradicted in future experiments. And they lay out an example of experimental science. In a laboratory, a biologist carefully counts out seeds and plants them in 2 containers of soil, one container held at a cooler temperature and one at a warmer temperature. She keeps them watered for several days and counts the seedlings when they appear. She calculates the fraction of seeds that actually sprouted, the germination rate, and notes that it is higher in warmer soil than cool soil. She decides on a model that seeds sprout better in warm soil than cool soil. Based on this model, she predicts that in very cold soil, no seeds will germinate, and in very hot soil, all seeds will germinate. To test this model and the prediction, she throws out the first batch of plants and runs the experiment again, this time using several containers of soil at several different temperatures. The results for cool and warm soil agree with the first experiment, confirming those results. No seeds sprouted in the coldest soil, confirming that prediction, but in the hottest soil, no seeds sprouted at all. She modifies her model. Germination rate increases with the soil temperature, but at the hottest temperature, the seeds are cooked before they can sprout. Second is observational science. Occasionally, for whatever reason, controlled experiments cannot be performed. There may be ethical reasons. It may not be able to fit in an experimentation lab, or the experiment itself may need to be conducted at the original location. Observational science is commonly done in meteorology, ecology, medicine, astronomy, and geology. Observations are periodic, since constant observation would be impossible. Observational science cannot be controlled, produced, or repeated. And finally, it makes testable predictions, like experimental science, that can be confirmed or contradicted in observations of other similar systems. The example given: an ecologist travels to the site where a forest fire occurred the previous year to study how the forest is recovering. He carefully counts all the plant seedlings in a certain area and notes what types of plants there are. For the next 10 years, he returns once a year to count the growing plants. he finds that wildflowers were the first to sprout and grow, but after some years tree seedlings are starting to compete with them. He hypothesizes that wildflowers grow better than tree seedlings in sunny, open spaces, but as the area gets crowded with plants and becomes shadier, the tree seedlings do better. He predicts the same recovery pattern will be observed at other forest fire sites, and that the growth of tree seedlings will depend on the amount of shade in the area. He repeats the observations at another fire site, where the fire was more widespread. Because fewer trees survived this fire, the site has less shade. He confirms his hypothesis that wildflowers are the first plants to appear, but sees many fewer tree seedlings than at the first site. This corresponds with his model that shady conditions are important for the appearance of tree seedlings. And finally, there is historical science. This will have particular bearing on the discussion of how evolution is compatible or incompatible with the Genesis account. This models past behavior of systems and is commonly used in ecology, climatology, astronomy, cosmology, evolutionary biology, geology, and paleontology. Its goal is to deduce the natural history of systems. Evidence available today is used to deduce history. There is again no controlled variable within the experiment, and like the previous two, it makes testable predictions supporting or contradicting their model for the history of the system. And an example of this: an ecologist travels to a remote forest in order to study its history. She first examines a large tree that has recently fallen down in a storm. She takes a thin slice of the trunk back to the laboratory and counts the tree rings. She finds that 131 years ago, a particular ring is extremely thin, indicating drought, and shows evidence of mild fire damage. She hypothesizes that much of the surrounding forest burned down 131 years ago, but this tree survived. Based on the work of her colleague, who studies recent forest fires, she makes predictions about the other trees living in the forest. The largest trees will show similar fire damage 131 years ago. Many of the smaller trees will prove to be 120 to 125 years old, having sprouted 5 to 10 years after the fire. To test this prediction, she takes core samples of several living trees and looks at their rings. The results confirm her prediction. The older trees all show fire damage 131 years ago, and many of the smaller trees are about 120 years old. So these are the various methodologies that are employed in order to determine what the exterior world is about, and what has happened in its past, what currently happens, what will happen in its future. The remaining question is whether or not these scientific methods employed are reliable. And true, some models are just guesses, while others are very well tested and affirmed. Scientists occasionally ignore potentially contradicting data, but to correct this, work must be evaluated by peer review before it is published in a scientific journal. The Harzmas, the author of Origins, state one or more scientists read the journal to verify that correct methods were used and documented, and that the conclusions are well supported by the data and arguments. If the work isn't up to these standards, it is sent back for revision or rejected altogether. A final question that remains, and this is particularly unique to the Christian examining the biblical data and also evaluating the scientific data, of whether or not we should allow science to interpret Scripture. There are some of a scripturalist camp, as they deem themselves, that believe that only Scripture should be evaluated when determining truth in its entirety. But let's examine that a bit more carefully. Again, the Harzmas state regarding this subject, basically Scripture is its own interpreter. Neither scientific knowledge nor theological expertise may function as prerequisites for right understanding of Scripture. In other words, we should not try to read current scientific data into Scripture, but simply let the text stand on its own. This is a statement of which I well agree with. I do think that Scripture needs to interpret itself, otherwise the interpretation is rather phony and seeks to reconcile itself with the scientific data at the cost of doing genuine justice to the interpretation. That said, however, I feel personally that if an interpretation is able to stand on its own and comport with the scientific data, it is wisest to prefer that interpretation. And so in the upcoming videos, I will examine the evidence for the age of the Earth, for evolution, and for the Big Bang Theory. And I will then consequently present the information for young Earth creationism, old Earth creationism, and a view called Ancient Near East cosmology. I will examine some of the pros and cons of these views, and I will seek to establish that Ancient Near East cosmology does the best justice not only to the biblical system, but also to the scientific data. That'll be all for this time, and I hope to see you all again. God bless.